Well, good morning, everybody. My name is Jasper. We're going to fly some drones today. Thank you for coming down. I want to thank the organizers for having me. I want to thank you for finding this room. I must be honest, it took a while for me to find it by myself. And I want to thank you all for putting yourself in harm's way to see these drones fly today. And keeping them under control, not using Java, but JavaScript, so it's even more exciting. So a little bit about me. I'm from Amsterdam. By day, I'm CTO of a sustainable scale-up in Amsterdam. We give homeowners advice how to make their house more sustainable. Wow, that's actually going to work. I think we still see the screen, right? Because the reason I need the light is for the drones to be able to know where they are. That's what I requested from the organization. This is my website, but by night, this is of course the most important thing. I'm a drone enthusiast. I just love these things. I just love flying them around. This was me. The image is a bit purple, but this was me in Spain this year when I was hiking. And of course, I had to bring my own drone and make all these Lord of the Rings shots, which made it more exciting, or it looked even more exciting than it already was. So what is the goal of this talk? Showing you how to control multiple drones using JavaScript. We're going to do that in 3 steps. So first, we need to figure out which drone we're going to use. In the second step, we're going to fly a single drone or control a single drone using JavaScript. And in the third step, we'll start controlling multiple drones at once using JavaScript. Questions, see me after the talk, but I think we have quite some time, so probably at the end we'll be able to facilitate some questions. Something a little bit legal, you are here at your own risk. This actually happened at, I think this was the Winter Olympics a few years ago, and I think that's a big drone coming down. But you are here at your own risk, but rest assured, these drones that I'll be flying today, they're very light. And they are not very powerful, so they won't really be able to hurt you. Yeah, the purple thing, it's just really purple. Let's try it again. Wow. It's just, it was as simple as that. Okay, I probably had the plug upside down. But if they do approach you, just kind of approach these drones as you would approach a horse with a flat hand. Just push them away and you'll be perfectly fine. Just like when you're feeding a horse, my mother always told me you have to use the flat hand. Just don't point your fingers. That's the most important thing because we have this cage and this cage is very useful and it works really well. Just don't point your finger because then, yeah, the cage doesn't really work. Let me just mute this. So yesterday, just for science, somebody told me that fingers, they resemble a hot dog. So I got myself a hot dog, and you see if you put the hot dog in, it just stops the rotor. So yeah, that's science for you, but you're safe. So the first step would be choosing the right drone. Of course, this is paramount. But before we choose the right drone, let's talk a little bit about the evolution of drones. So 10 years ago, this is actually me. This is a time-lapse of me building my first drone. So 10 years ago, you had to solder these drones yourself. There was this one German guy who was building microcontrollers that you could use to build these drones. But 10 years ago, the first time I saw a drone fly, I was just amazed. By now, we're really used to them. But this was 10 years ago. So this was, the beginning of drones. And this is my maiden flight. And you'll see I'm not very good yet, because I was just so scared of breaking the drone. It took me 2 weeks to build. So you see me just crashing into the bushes a lot. So then the next step is that a lot of people, they started seeing the potential of these drones, because these drones, of course, these are they really understood like these are amazing pieces of hardware. So they started building RTF packages, which basically means a ready-to-fly package. You no longer needed to solder this whole drone yourself. You could just go to the shop, you could buy a drone, and the same afternoon you'd be flying. This one it's the DJI Phantom, I believe, and it goes for about 2,000 euros. So So that was, I mean, yeah, so they became, you could buy a drone yourself, but you couldn't really experiment with them yet, because I don't know about you guys, but I don't have 2,000 euros lying around to experiment, because if you start experimenting with these drones, you start crashing a lot, and these drones, as soon as they crash, you saw it in the Winter Olympic one, they just, they explode, and you have to buy a new drone. So that's why the third step is kind of important. And that's the cheap, simple drones. That's been like, those have been around for a few years now. And that opens a whole big list of opportunities. So that's kind of what brought us here, these simple, cheap drones. So let's talk about the requirements for doing what we want to do. So first of all, they need to be cheap. As I said before, if you start experimenting, you start crashing a lot, and you don't want to throw away 2,000 euros every time that you crash. So I think that's obvious. For me personally, I want them to fly indoors, because this takes a lot of time, and like if the weather is not so nice, I'm from Amsterdam, so we don't have a lot of nice weather. We have 2 days of summer every year. So we want to be able to sit inside and be comfortable, and also there are a lot of, there's less wind inside. It's a bit more of a predictable environment. They shouldn't be too dangerous. We talked about that before. And of course, they should have an interface for communication, because that's when the fun starts, as soon as you can start telling your drone what to do. And then, of course, I'm talking not about this regular controller, but a computer interface. So the drone of choice in this case, it's a company called RiseTech, and it's the Tello. That's it. I mean, the slides will be online later. It's this drone. This is what it looks like. So it's relatively cheap. I mean, it's still 100 euros, so it's not throwaway money, but it's a lot better than the 2,000 euros we saw before. It's really light, so that's nice. Including the battery and the cage, it's 95 grams. So, and as discussed before, the lighter a drone is, the safer it is, basically, because it won't be as powerful and won't be able to hurt you. So this drone, it has a UDP interface. So this is a protocol. We'll be talking about that later, but that's the protocol that this drone uses for the communication. It doesn't have any GPS, which is maybe a little bit obvious for this price, and it's also better because it's lighter that way, and we're going to fly it indoor, though, so we don't need the GPS. But what is more important, and that's the whole thing with the lighting just now, and that's also the bed sheets, which I will be explaining later, is it has downward-facing cameras. So you probably won't see it all the way in the back, so just believe me, there are two very small, cheap cameras in this drone, which are pointing downwards. And these are the cameras that we're going to use today. So let's talk about these downward-facing cameras. So what these cameras do is basically they use the cameras to do onboard visual recognition of patterns on the ground. And why do we need that? We need that to keep the drone in place. So the way that a drone works, it's very simple. So you have 4 rotors. So basically it provides lift just like a helicopter does, by just providing downwards thrust, and that's how it stays in the air. Now, the big problem with helicopters or with drones or any of these kind of non-airplane planes or aircrafts is that they are very unstable. There's no reason for a drone to stay upright. So it will just as well hang like this or this. And if this happens, you actually see that the thrust is no longer pointing downwards, but it's pointing that way. So this is how a drone actually moves. By doing like this, you probably saw it when you saw a drone fly. This is how a drone actually moves. But the drone doesn't know whether it's exactly upright. So there will always be a slight drift because it's just not perfect. It has some accelerometer, so it kind of knows if it's upright, but it will never be perfect, so it will start to drift. So what will happen is that it will use its cameras. Normally the outdoor drones, they use GPS, but this one will use its camera to take kind of pictures of the ground and to determine whether it's moving. So if it's moving a little bit like this, so it's moving that way, and it sees that on the ground, then it just compensates a little bit by going a bit like that. It will drift a bit back. If you do that like 100 times a second, it will appear to be staying in the same place. And of course, kind of the next step would be if you do want to move somewhere. So if my drone is flying here, and I want to move there, then I probably have an idea how far I want to move. So maybe like this is, I don't know, like 80 centimeters. So I send a command to the drone, fly 80 centimeters that way. Then somehow it needs to figure out how far it's flown until now. Like it doesn't have any like, airspeed meters or anything, and that would be very difficult also. So again, it uses the visual patterns on the ground to determine how far it was flying. So whether it needs to stop if it's already on at the 80 centimeters I told him to go. So that's the reason why we have these very strange bed covers here. Because if you look at the normal ground here, it's completely gray. And again, it's a relatively cheap drone. So these cameras aren't perfect cameras. So if it's flying over this piece of gray, it will just not understand where it is. And I will tell you, if I take off here, it will just immediately start just flying off and you would have no control. So that's why my daughter is a bit cold tonight. I cut up these bed sheets, and these are very specific also, because you could take other bed sheets or other patterns, but if you have a very small repeating pattern, again, so then this piece of pattern would be the same as this part, as this part, as this part. So you would kind of maybe intuitively already feel that the pattern recognition will be a lot more difficult than when you have these very big, childlike, high contrast patterns. So that's the reason for the Despicable Me bed covers. So let's go to step 2, and that's really actually controlling a single drone. So what do you need to do to talk to a drone? Basically, you need to send commands, and you need to receive telemetry. So you want to tell the drone what to do, and the drone needs to tell you what it's doing, or where it is, or what he thinks is happening. So we use a communication, so this drone uses a communication protocol, just UDP. We all know TCP, we probably all also know UDP, and UDP is basically, it's a best effort protocol. So it's very low overhead, it's very small, so that's very good for these kind of types of communication. But the big problem is you don't get any feedback. So that's kind of the whole best effort thing, is you send a message. With TCP, you can get immediate feedback. It will tell you like, yeah, message received, or maybe even, I don't understand this message, or you gave me some wrong parameters. That's the thing you don't know. So you send them, and then on another port, you're receiving telemetry. So you kind of have to start matching this together, and we'll get back to that later. As soon as you start sending commands, and you actually you want to know whether the command was successful or whether it already arrived at the next point, and we want to send our next command. So for now, we'll just do it kind of the cheaty way, the easy way, and we'll just build in some waits, some timeouts, we'll wait for a few seconds. So say you say a command, go to the left, I figure it will take about 4 seconds, so we just wait for 4 seconds and then we send the next command. So let's start flying with the first drone. Let me close this one. Yes, there we are. Probably make this a bit bigger. Yes. Send. And let's go to the code. So let's talk a little bit about the code that we're using. So at the beginning, it's quite simple. So we have some imports, basically a library that we use for the UDP socket. Some constants, so we have our part and we have our IP address. We set up a socket. We have a very simple helper for sending commands, which does some logging, and also this is a very rudimentary library, which also needs the length of the command. So basically, it's not much more than just doing a client.send. That's what we're doing here. So this is here. This is where we actually send the commands. So as you will see, we have the first command as command, which is very specific for this drone. It basically puts the drone in the SDK mode. So it kind of, with the command, you're basically telling the drone, I'm going to send you more commands, so please be receptive for it. And at that point, it also starts sending back the telemetry to your laptop or to your code, so you can start interpreting what the drone is doing. Let me just see. So if we say command, so it's in the init mode, it won't listen to any other controllers anymore. So that's also important, so nobody can you can control the drone also with like an app on your phone, but that's more the playful thing. In this way, you're telling him, we're going to send you kind of, API commands. So the first thing we would maybe do is say, let me see, it's on, so that's good. So you would say takeoff, right? So we would say takeoff, and we would send it. Whoa. Let me just see. I have a bit bad reception, so I actually brought my own. Let me just see. Does anybody know this code? I've never seen that one before. But I do think that it's... No connection. Let me just see, because yeah, we're kind of in a bunker here. So I saw this before, and I brought my own Wi-Fi connection. So let's see if I can make a connection there. Okay, so thank you. So we just send our command, and we send takeoff. So, okay, so now it took off. Now we need to get back quick to our code. So we say takeoff, and let's say land. So basically, that's kind of the first thing that we did, right? So we're sending a command. We say takeoff. We wait for a few seconds, and then we send our next command. So that wasn't very exciting yet. So let's do a quick takeoff. Like go left 100, and then go right 100, and then we land. So there we go. So let's see if that works. I think that would, normally 3 is okay. So we send command, we say takeoff, it took off. I said left 100, but it didn't really react. But with right, it did go and land. Yeah, so that's basically land. Yes! So what you did see is we saw a few commands. We saw the command, we saw the takeoff, we saw the left 100, and then it didn't really react yet. So that's immediately already the problem that we have, is that probably it just wasn't ready yet. And if it's not ready yet, it's not going to queue these commands or anything. It's just, it's just going to wait, or it's just going to ignore the command. And then by the time it was ready, the left command was already sent, and then we sent the right command, and basically it was ready then. So you saw it flying to the right for 100 centimeters, and then it did land. So it's kind of tricky in the beginning to really set this up. So basically, what you would have to build yourself is just kind of a queue where you set up all the messages, and then you start inspecting the telemetry to determine whether the command was successful or not. So let's talk a little bit about the telemetry. So we send the command. I'm just going to send it so we are in contact. And now let's receive some information. So this is, again, kind of similar code. We have our library, dgram, we have our port, we create the socket, and we're just going to, on the event of a message, we're just going to log it to the console. It's as simple as that. So, let me just make sure. So it needs to, yes. So here, so basically what's happening right now, I think this is at 10 hertz, so this would be 10 messages a second. This is the telemetry that's coming in. It's just one big string. So here you already see, I'll zoom in a little bit more later, but you'll see that there's just a lot of information here. So for instance, just here, this is the pitch. So the pitch of a plane or of an aircraft is this movement, and you'll see that if I pitch the drone, you see this number changing. So, and if you roll it, you see this number changing. So let's zoom in a little bit more so you can see it a bit better. So here you see it. So there's a lot of stuff going on. So you get your X, you get your Y. We'll talk about that later. You've got your pitch, you've got your roll, you've got your yaw, and then a lot of other things. So basically, that's our telemetry. It's just a string coming in. So I kind of assume that a lot of you are pretty good developers, so just kind of extracting this information from a string, that's probably not going to be the most exciting part. So we have our information. So that's interesting. So this is the stuff that you're working with. So this is kind of a constant barrage of information about its position, about what it's doing, about its speed, et cetera, et cetera. Okay, so then let's go to the next part, which is the more exciting part, is of course what you need to do to control multiple drones at once. So basically, if you start controlling multiple drones at once, you're talking about coordinated flight. You've got several aircrafts in the air, and you just want to make them behave in a way that kind of is in communication or in coordination with the other drones. So in order for this to happen, if you have several drones flying here, basically the most important thing, what they need to know is where they are relative to each other, right? So if you would have a drone here and another drone here, you don't want them to hit each other, so they need to know where they are relative to each other. In order for a drone to know where it is relative to another drone, you basically need to tell the drone, or the drone needs to know where it is relative in a space. So let's talk about a certain space. That's just this space, so those would be our coordinates. But the drone needs to know where it is. So that's why we have these mission pads. These are these pads, and these pads, as you can probably see, and hopefully also all the way in the back, they have a very distinct pattern. So a few different colors. If you see these colorblind pictures for people who are colorblind, that they can see certain patterns. These are these exact colors. And the location of these patterns are very specific. So that means that these mission pads are recognized by the downward-facing camera. So if the drone is flying over one of these mission pads, it will know that this, by any chance, this is a mission pad with ID 1. This is just for humans. It won't read this number. It's just for us to see kind of which mission pad it is. It will recognize the mission pad. And every mission pad, it's unique. So it will recognize 8 different mission pads which are on the floor. So what happens is that a drone, it coordinates its position relative to this pad. So if this pad is here, you can get the relative position compared to this pad. So this will be a different position than this position. As we saw before, with the telemetry coming in, you also saw an X, a Y, and a Z. And basically, that's the X and Y and Z of the drone relative to the pad. So that's a thing that is maybe a little bit difficult to see because there's so much contrast and so much going on. We have 8 pads lying down here. So this is like 1, 2, 3, 4, 5, 6, 7, 8. And that's basically this pattern. So the pattern that you see over there, it's the pattern that we have on the ground. And of course, I put this down in a very specific grid. So I know the exact coordinates of the pad. So by combining the relative position of one of these drones compared to these pads, you basically know where the drone is in the absolute space. So let's go back to the telemetry we had before. So here you see MID. That just means that the drone is flying over mission pad 2 at this point, and that the x is 73 and the y is 18. By the way, the coordinates are in centimeters. So it just knows that right now, 73, that's like about this distance, and then 18 on the x is about this distance. So it just knows that it's flying somewhere here. You also see the z, by the way, but just to simplify, I just mentioned only the x and the y. So now we have the current position of the drone because we have the mission pad and we have the relative x and the y. So the code to get this becomes pretty simple. So you have the x and the y of the pad, you have the relative x and the relative y of the drone, and to get the x and the y of the drone, you get the x. You just combine the pad x with the relative x, and same goes for the y. So when you want to generate a command, just the syntax, it's very specific for the drone. If you want to go 10 centimeters on the x and 100 centimeters on the y, then this is basically your command. So at first, you get the position, you have the target x and the target y, and basically you calculate your delta x and your delta y, and that's how you create you generate the command. So give me 1 minute to set this up, because I want to show you a few drones flying in, well, you can call it a dance, but coordinated flight. But I just need to position them in a specific place, because I've learned the hard way that if you just put them down, and then of course you have 2 drones that need to be in the exact opposite spot, it becomes interesting. So we've got this one, we've got that one. Are they all on? They are. Am I connected? I am. Okay, so this one is closed, this one is closed. So we start the back end. This code, I'll upload it to GitHub later if you want to take a look. For now, we don't really have enough time to go into the code for the backend. I've built a very small React front end. This is absolutely not a React front end talk because it looks horrible. But I use this to control the drones. Oh, I'm still in my presentation. Yes. So this is a small HUD, which basically every column is one of the drones that are used for controlling it. It's too much in depth to go into that HUD, but again, it's just kind of a lot of React buttons just to send a lot of commands to the back end. So we send one init to all the drones. And so you see a little bit of telemetry. You see that the drones that we weren't using yet, they still have 100% battery. And the blue or the gray drone that we were flying already for just 1 minute has a little bit less battery. Okay. So now I really hope that we have enough light here, because again, we are using the cameras on board. And let's see if this works. Okay, so we got them all to take off and we got them all to land. So let's do another takeoff. There's always this one guy who doesn't really want to. Yes. Okay, so we're all flying. And land, 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 land. Yes. Okay, so we have our first kind of like 4 drones which are kind of listening to what we're saying, so that's good. So now let's make this a little bit more interesting. So we initialize, they all take off. Yes. And now I just put in some. So right now I press the dance button and I just put in a lot of coordinates that they need to kind of in sync execute. So you see them all waiting for each other. And so like this is what I call a dance. It's probably like, now you kind of understand what my quality of dance is. So you see they're turning around, they're all turning. So what's happening right now is that in the background, there's just a constant coordination of what's going on, and they're waiting for each other, and they're trying to kind of not run into each other. And basically, they're dancing. I never really know when. I think they're almost finished, and then they should automatically all land. So this is not me doing anything. Yes! So that's it. So here we have some... And I'll explain you guys how this happened. So they do tend to overheat really quickly. That's why you see me turning them on and off all the time, because they use the passive airflow for cooling, but if they're on the ground, they'll get hot really quickly. So how do they dance? What just happened? It's not that complex. It's not rocket science. It's not Java. How do they dance? Basically, we have our coordinates here. So we have a drone. That's why I put them in a specific place, of course, in the beginning. This is their beginning spot. And then if you want to go to the next spot, basically this would be the first step of the dance. Then we just have a helper function which just takes an x and a y. It also takes a z, but I just left them out again for simplicity. You just send the command. You send the command to all the drones, and in the background, what I'm kind of doing is constantly inspecting the telemetry to see whether I feel confident if the drone is at the next spot yet. As we saw in the beginning of the talk with the one drone who kind of did the takeoff, and you send the command too quickly, then it just ignores it. So that's why it's paramount that you keep inspecting the telemetry to determine where the drone is at that point. So some lessons learned about flying some drones. It's really, really hard. The fact that, I will be honest with you, I'm really happy that they stayed in their place and they did what they needed to do, because this took a lot of trial and error to get this right. And why is this? This is just because controlling drones is really hard. There's a lot of external factors. I'm a software engineer myself, so normally, and I think most of the people here are software engineers. And that's why I also think this is really funny. As soon as you get into the hardware realm, the predictability goes down crazy-like. Because when a server is running, or when you have a process running and it has a certain, maybe there's too much memory being used, like this is still a pretty controlled environment, like your OS or your Docker or your container, it will always be the same. In hardware, right now, this is pretty okay because we're kind of sealed. But I was in another room where if you would open the door, there would be a draft. And suddenly all these drones started moving because there was just this slight draft. And then you would have to compensate for this. I had a move where the drones were doing this, and suddenly the downdraft of this drone was pushing down the other drone. So this kind of makes it all very unpredictable. So these are the external factors. Also, these are cheap drones, so the quality of the sensory input, it's so-so. So what you would see a lot, what I would if I would have my drone here and you saw a move that would have the drone moving there, because of the quality of the sensory input, the quality, like its direction wasn't always the best. So a lot of times it would fly here, or it would fly there, or it would fly slightly there. And of course, one time it wouldn't be too bad, but if your starting point is somewhere completely different than you expect it to be, then the next move would go haywire. So you would have to do a lot of compensation during the movement as well. So just a little bit of advice if you want to start trying this at home. Get rid of your cats. So I have a cat at home, and they go crazy when they see a drone. So they actually attack, and a few times I had my cat attacking my drones. But also get rid of your plants, because the drones on their side, they attack plants. So a lot of times I would just be flying, and then by now I know this very distinct sound of my drone flying into my plants, and you would get all the pieces of plants flying through the room. So get rid of your plants. Get prepared to crash a lot. This happens, it's just, yeah, that's with hardware, and especially with flying hardware, you crash a lot. And I just love this movie, because look at his expression when it goes into the water. He's just so disappointed. It's just, I think that's funny. You need to create your own coordinate feedback system, or command feedback system. Because this is UDP, this is maybe the most tricky part also, that you kind of have this dance where stuff is coming in and you're sending it out. And yeah, it's no TCP. One of the downsides of this platform, it's really fun, and it's kind of the cheapest platform that I could find out there that's able to do this stuff, is that part of what this drone is running is proprietary software. So this, it doesn't really feel that right, because the mission pads that I shown before these, they're actually sold by the same company, and they are hardwired into this drone. So for anything like, if I want to do this, I want to scale this, and I want to put down a lot more pads, it's not really possible, because I don't have access to the software to add more pads, which I think is a bit of a shame. Thank you. If there are any questions, I'm very happy to answer them right now. Yes. Yeah, so the question is if there's an open source platform to kind of achieve the same. There absolutely is. I think it's like there are several initiatives. I think the biggest one, it's called Open UAV, like Unmanned Aerial Vehicle or something like that. So of course, yes, they are absolutely there. The biggest problem there is that it's like it's very there's a very high bar of entry, because you have to build your own drones, and you cannot build your own drone for $100 like that. That's going to be near impossible. So this is just, you know, they build them in China, and they build them by bulk, so that's why they're so cheap. But if you want to do open source, then you have to buy your own hardware, which is really cool, and if you're doing it for one drone, it's absolutely worth it. But for my purpose, when I was doing a lot of experimentation, it would be too big of a bar. So, I mean, for me, it's fun this way. And then if you would maybe do another project where you're really focusing on one drone, then yes. And you see, I think like a month ago or 2 months ago, in the coronation of the King of Thailand, they had these drone shows, and you see a lot of drone shows now. Yes, these, well, you're talking about very different budgets there than cheapy me trying to do this in my basement. Yeah. Yeah, yeah, so the question is whether there are alternatives to the mission pad. So basically, when you're inside, the big challenge is to know where you are. So we like the GPS is already difficult inside. Well, let's call it impossible inside. So you have two options. Either you do the determination of the drone or of the position of the drone inside the drone itself. So let the drone kind of figure out where it is, or you do external determination of where the drone is. So you see, probably you all know the HTV5, is it called? Like the VR headset. They have these satellites. And basically that's the other way, where you kind of do an external camera and you start figuring out, based on the camera input, where the drone is. I've experimented with that a lot. It's very accurate. That's the big upside. So if you would do kind of an external sensor, it's very accurate. The big problem arises if you have several drones at once, because then, if say you have a camera over there and you have two drones flying like this, first of all, it's kind of hard to figure out which drone is which. So you see two drones, but how do you know this is the white and the blue one? Of course, it's white and blue, but I'm not sure if the camera will see. So if you if you start flying with a lot of drones, you need something on board. And then the visual recognition is one of the options. You could do stuff. I've seen initiatives also with like Bluetooth, where they kind of take the signal strength. But yeah, as soon as you're doing it on board, then you're kind of limited by the hardware. I think I need to set it up. Give me 1 minute. We'll can do it in the change. If there are no questions, I'll set it up again, and I'll make them dance again. No more questions? Okay, then I do want to thank you for your time.